All right, so where am I going here? Let's see. This is identity here. 1 plus tan squared of x times 1 minus sine squared of x is always going to be equal to 1. So I'm just going to be making use of those Pythagoras trig identities. So we know that tan squared of x plus 1 equals sec squared x. And that's from our formula sheet. If I just go at the top there, you can see there it is, the second one. And that enables us really to make a direct substitution here. So where you see the 1 plus tan squared x in the bracket, we can replace that with sec squared of x. And we multiply that here. Now if we expand those brackets, hopefully things will fall into place. Let's have a look. We end up with sec squared of x minus. Now if we just, I'll expand this in full first so then you can then see it. We can rewrite that sec squared as 1 over cosine. So that will look something like this. And obviously when we combine those two into one term, and I know I'm doing this in multiple steps, you could probably abbreviate that last term, I think. We've now got this little bit here, sine squared x over cosine squared x, that's the same as tan squared of x. So we now have the first part here minus tan squared of x. And we know that from this identity that we had over here at the top, that if we rearranged that, we could say that 1 is equal to sec squared of x minus tan squared of x, which is what we have down the bottom. So therefore we have actually shown that that is equal to the right hand side. Well, actually we should probably do it one more step, I guess. Maybe we should do that. Where we know that, I don't know how you want to do this, you could say sec squared is equal to tan x plus 1, so we could substitute that in. I guess we've probably been a bit finicky here, but I guess if we want to go right through it with rigor, and then those two cancel out, leaving us the right hand side. That's probably best to be safe. I think it would have been okay to stop at here, but possibly better to do those extra 2 steps. So there you go.